November 2025, CloudFlare broke the internet. It wasn't a hack, wasn't a complex code bug. It was a data pipeline that created duplicate rows. So instead, it was triggered by a change to one of our database systems, permissions, which caused the database to output multiple entries into a feature file used by our bot management system. So in short, a data pipeline that successfully was deployed, and it hit a configuration file with duplicate rows. The pipeline continued to be green, validations passed, and that engineer left for the day. That successful pipeline ended up triggering a massive outage because the downstream systems couldn't handle the semantic error. In Cloudflare, the people who run the infrastructure of the web can be taken down by a green DAG. What's the chance that you think your startup has? For the last 10 years, you've been trained to worship that green box in Airflow, Dagster, Databricks job. If you think that task turns green, you did your job. I'm here to tell you that in 2026, a green DAG is often just a confident liar. If you feed garbage data into a dashboard, a human spots it. If you feed garbage data into an AI agent, it doesn't get annoyed. It doesn't come and call you. It doesn't Slack you at 10 a.m. and ask you what's wrong with the data. It hallucinates rationale and executes those transactions. Today, we're going to tear down your orchestration strategy and rebuild it with only the pattern that actually works: circuit breakers. Why does this happen? Because we end up trusting that green light more than the data itself. I once audited a pipeline for a major services firm. The pipeline processed time entry data for client billing, and it was literally the code to cash pipeline for the company. Every day that pipeline ran green, and every day the log said success. But the engineer had a flaw in the partition logic. The job was correctly processing the current year's data, and if you looked at a year-to-date dashboard, all the numbers matched perfectly. Everyone was happy. But in the background, the Spark mode was set to overwrite, and it was January, and the pipeline was refreshing the current month each day. So every morning, the pipeline was silently deleting all the previous calendar month's data. Because the executive dashboard defaulted to the current fiscal year, nobody noticed or looked at the history. It took them 30 days until the most recent year-over-year audit to realize that 5 years of previous data were gone. They were flying blind for a month because their operational view was green, but their historical truth was empty. Now, here's the nightmare scenario for 2026. In 2020, that mistake cost them a panic attack and restoring all of that data from previous loads. If that happens going forward, and you have AI built into your systems, something like a churn prediction agent that was reading that table, the agent would see zero lifetime history for all of your biggest clients, assume they're new, low-value accounts, and auto-downgrade their service tier. That green DAG wouldn't just lose data, it would lose all kinds of customers and cause your churn to skyrocket. So, let's look at your tools. I don't care about the UI. I care about how you portray you. I call this one the orchestration torture test. First, the time machine, Airflow and Backfills. Junior engineers end up worrying about the daily runs, while senior and staff engineers know that they're going to have to backfill someday. Airflow and Databricks are great at running today's job, but when you need to restate the last 6 months of data, they start to fall apart, and you need to trigger some type of backfill to make sure that things are idempotent. You can write scripts that can handle these types of situations. So when you're building your orchestration, when you're writing your pipelines, make sure that you're going to account for having to backfill, not just the first time, but periodically. You never know when something's going to come up. Because if you trigger a backfill in Airflow without perfect idempotent write logic, you aren't just fixing your data, you're actually duplicating it. I've seen backfills for that double counted revenue because the engineer thought that catch-up equals true. And that just was part of the feature that they built in. It became a weapon for their orchestration. Second is the try-catch trap. This is one of my pet peeves, and I see it constantly in the notebooks that I am PRing for various people. Now, you end up writing your code in this generic try except block to keep the pipeline moving because you're afraid that you're going to get a call at 3 a.m. that your notebook catches and fails, right? So all of a sudden, you need to wake up at 3 a.m. and you don't want to do that. So you start just generically adding in these try except blocks. Now, here's the thing. Those are silently erroring out over time. That's what causes the thing like we just talked about. Now, your AI model is just an empty table, right? It is really just a big bucket that's collecting that data. The job is green. The model is effectively lobotomized, though. And this is a success that ends up costing you your career because secretly it is actually failing. Now, third is the AI tax. Vector indexes is what we're talking about here. Here is the new cost for 2026. If a dashboard breaks, you apologize. You feed bad data into a vector database for a RAG agent. You just corrupted the brain of your AI. Now you have to burn down the whole index and pay to re-embed 10 million documents. That isn't just embarrassing, it is a $20,000 compute bill because you were too lazy to validate schemas. So, how do we fix all this? We stop writing directly into production. We need to implement WAP, write, audit, publish patterns. So, listen closely. You can't do this with raw Parquet files unless you want to write your own locking mechanism around them. You need table formats like Delta Lake or Iceberg. Step 1, write to a staging branch. Your pipeline runs, but writes to a hidden staging table or temporary version. No downstream consumers here, and certainly no AI agents are allowed to see any of this data. Step 2 is the audit. This is going to be your circuit breaker. This is where the magic actually happens. You run a backlog validation task to check things like the contracts. So if you don't have data contracts or know what they are, go out and figure it out and start implementing them. The row count. So you identify, hey, these row counts dropped by 50%. I need to look at this. Or there were 0 rows ingested. I really need to look at this right now. There are duplicates in the primary keys. That's a big one. Hopefully you've built your system around the fact that that can't happen, but many people are in a hurry and don't. And also, is the data fresh? So looking for some recent dates that have some transactions. If any of these fail, you don't append to production. You send the alerts, you kill that pipeline, and you trigger that circuit breaker. You leave that bad data isolated in that branch, and that way the AI agent continues to read yesterday's data, which is stale, but it is way better than today's data that's fresh but wrong. Now, step 3, the atomic merge. Only after the audit passes do you flip that switch. In Delta Lake, this is a atomic transaction. In Iceberg, it's a branch merge. The world only sees the data after it has been proven innocent. You want to make sure all of your validations check has passed, right? Make sure those audit has all passed, make sure the data is actually there, and then write it into production, regardless of which layer of your medallion layer it's going to land in. Now, right now you're saying, Chris, isn't that over engineering? Really, I need to hurry up and get this done. Absolutely. Sometimes you have to get things done in order to please the business. However, know that you are definitely creating tech debt if you don't. I'm here to tell you that doing these steps is part of the insurance, not just for you, but for the company. In Airflow, we use Airflow fail exceptions to fail a task instantly without retrying if a data quality check fails. Don't let it continue to retry and push that corrupted data into your production environment. In Databricks, use run-if dependencies. The published task should only run if the validated task returns that specific success key. So again, if you're in Databricks jobs, you need to fail loud. The task needs to fail so that the downstream tasks don't run. In Dagster, we use asset checks. Block downstream materialization if those checks actually fail. All of this adds maybe 5 minutes to your runtime. But go out and ask one of the Cloudflare engineers if they would have traded 5 minutes of latency to avoid breaking the internet for 3/4 of the world. 5 minutes of validation is cheaper than an outage that is going to hit the company's trust and bottom line. The time to move fast and break things is over in 2026. If you break things now, you're breaking an algorithm, and that algorithm is ending up breaking the bank for you and your business. So stop building confident liars. Go into your orchestrator today, find a critical pipeline, and ask yourself, is this job turning green and the data's actually wrong? Well, I know before my COO calls me. I don't want to get that call from Amy. And if the answer is no, then you have some work to do. And if you've missed the rest of the roadmap, be sure to go back and check that out right now.